So I'm going to have 2 videos about this question, and each video is going to be based on the opposite version of the exam. So this version of the exam is the one where it's spelled O-N-E this way, capital O-N-E. So this version of the exam, I'm going to show you how to do this problem 1A, 1A, and little algebra. And the other video is going to show you how to do it with algebra. Okay, so I want you to think about what's happening to this graph. All right, so the domain, let me zoom in. Okay, if you zoom in, you see what's happening to the domain. The domain goes from 0, 10, sorry, it goes from 1 to 10, and it goes from this point to 30. So you have to think about what's going on first of all. This is 10, and this one's 30. This one is 1. And so this point, so here's what you're thinking. You should think, okay, what is that subdivision? What's going on here? And she said they're all on integer value coordinates. So you think, oh, this one looks like it's about halfway. So this distance must be 2, and this distance must be what 3 looks like. So, and I also gave you some more clues. I told you 21 was in the graph, so this is what 1 looks like, which tells you that this is what 4 looks like. So now you have something against which to judge. And so you can say, well, does this look like a 2 or a 3? Well, this one is bigger, this piece here is bigger than this piece. So this must be a 2-3 split. It's definitely not a 1-4 split. So it's a 2-3 split. So this must be a 3. So maybe it takes you a couple seconds to figure that out. And then the range is easy. The range is going from -2 to 3, and it's going from -3 to 2. Okay, so let's talk about, oh, and the other thing you have to be aware of is you have to know whether this thing flipped or not. So if you look at what happened, you say, oh, wait a second, this flipped just based on the fact that this peak ended up over here. And then you say, oh, hold on a second, this distance from here to here, this distance is 2, and this distance is also 2. So you realize that this thing flipped, but that there's no other thing going on in the y-axis. So the y-axis, on the y-axis, which I'm calling the output, this is the output of your function, it flips, but nothing else happens. Okay, so the question is, fine, what happens on the x-axis, or the input, what happens in this direction? Okay, so let's see what's going on. You're going from 1 to 10, and that becomes 3 to 30, and you look, is there any flipping? No. We're moving in this direction in both graphs, so there's no flipping on this axis. So it's a strict, we're strictly going from 1 to 10 becomes 3 to 30. So actually this is just times 3 in this direction, but we really need to calculate this direction, which is a divide by 3. And what's going on here? So you want to say g of x is some function. So g of x we know is negative f of something. And if we were to put, so a lot of people will mistakenly put 3x, so let's try that, see what happens. If we put, what is this, 15, x is equal to 15. If we said f of 3x, we'd be trying to look for a 45 over here, so we know that's going the wrong direction. It must be divide by 3, so we've got the thing flipped around if we're trying to put 3x in there. So try it with x over 3, and you say, aha, that's what I meant to do. I meant to take this x, divide by 3 to get over here, so I can look at this point instead of this point. Okay? And so if you have what you think is right, then just double check a couple points. Say, hold on, is this right? If I put x is 3 over here, I get minus f of 1, and that's this point gets flipped down to here. That's correct. Let me try the 30. F of negative f of 30 over 3 is negative f of 10, which is negative 3, which is correct. So that's how you do this, by just looking at the picture. Let me just go ahead and show you the other version of the exam for a second. Okay, I'm going to use the non-algebraic method on this one too. So I'm looking at the domain is going from 1 to 10, and then it's going to, the same logic I used before. This is a 3-2 split, so this must be 8, and so this must be either 26 or 27, right? So is this a 1 or is this a 2? And so I look and say, aha, if I have a 12, 4, then this must be what 2 looks like. This must be what a 2 looks like, and this must be what a 3 looks like. So this must be a 1, because it's definitely smaller than this 2. See, that gap is smaller than that gap. So that's a 26. And so if I'm going, and I see that has this been flipped, I have to look. Yes, there's been a flip. There's been a flip. It's because this thing ended up here, but we're still running in this direction. So there's only one flip. The flip is on the output side. And so we know that we're going to get g of x is equal to minus something or other. But then we ask ourselves this question, what's this distance here? This distance is 2, and this distance is 4. So it's minus 2. That's the factor. And I'm also noticing that there's no plus over here. There's no shifting up and down. So that's good. And so we just need the innards. Now we have to figure out the other direction. Okay, so it's going from negative 2 to 3, and it's going from negative 6 to 4. Remember that, I'm sorry, I did that part already. We need to worry about the input side now. Sorry about that. Okay, so we need to worry about this part. Okay, so 1 to 10 becomes 8 to 26, and we know there's no flipping in that direction, so it's going in the right direction. So what's happening? We're looking at this. This distance is 9. What's this distance? 26 minus 8. So we get 18. So this direction is times 2. So this direction is divide by 2. And that's the direction we're worried about. But we need to shift it a little bit. So there's a lot of things you can do. You can just figure it out and say, wait, if I took 8 and divided by 2, I'd get 4, and 26 and divided by 2, I'd get 13, and then in both cases they're off by 3. So if I consider these to be the x's and these are the t's, I could say x is equal to t over 2 and then minus 3. But if you decide to subtract first, it would be bundled differently. Okay, but in any case, you have to double check t over 2 minus 3. Let's double check that this is right. So we just take some point over here. 20 is easy. If x is 20, 20 divided by 2 is 10. 10 minus 3 is 7. So you're looking at the 7 over here. So the answer is 3 times negative, this 3 times negative 2 gives you the negative 6 down here. And so that one worked. Let's try another one. Let's try 8. If I put 8 in for t, I get 4 minus 3 is 1. So I look at 1, I get 3 times negative 2 is 6. Actually negative 6. And so that's what I get down here. So that one worked out. So if 2 of them work out, it's probably good. You probably want to test at least 2 points. And that's the visual. This is the visual method. And I'm looking at just the domain and range and just looking at the structure of the graph. This is a useful technique if I give you 2 graphs. You can do that.